Good morning. Good morning, one and all. On behalf of Sant Gajanan Maharaj College of Engineering, Institutions Innovation Council, first of all, I would like to welcome resource person of this today's session, Mr. Baba Sahib, Techno Commercial at Skipper Nigeria Limited. So first of all, I will introduce shortly. Baba Sahib Mukne is a passionate energy conservationist, has over 13 years of rich global experience in leading engineering management. He has mastered the administration of developing solar photovoltaic power plants, project planning and management, energy efficiency solution in the thermal utilities, electrical utilities, and its energy performance assessment for equipment and utility systems, solar thermal procurement and negotiation and techno-commercial management. He has involved in $15 million energy-related projects around the world. He is a public speaker and interviewed by TV channel and received the prestigious international award. He received recently the prestigious Global Listing Award 50 Most Influential Solar and Green Energy Leaders. He is certified solar designer professional, solar installer professional, and holds several other certifications. Mukne has worked with multiple organizations across the world, including India, Gulf, and Africa country. He is currently leading the Deputy Chief of Staff Techno Commercial at Skipper Nigeria Limited. So with this short introduction, I request Mr. Baba Sahib Mukne to take the charge of this today's session. Over to you, sir.
Thank you so much for giving the big introduction, Mr. Mane sir, and good morning to all of you. I hope I'm audible to everybody. I will share my screen just now. My screen is, I think my screen is visible to everybody, correct? Hello? Hello?
Yes, sir. You are audible as
Yes,
well as
yes.
screen is visible, sir.
Yeah.
Equally.
Good morning to all of you. And first of all, thank you so much for giving me the opportunity to give the webinar on the important topic of the world. I think welcome to webinar. This topic of this webinar is the beautiful future of solar power in India and its employment opportunity. This is some of the important things we need to follow during this webinar. Actually, I'm requesting to everybody keep all your phone in mute mode and mic also off. That will be helpful for giving the brief introduction regarding this important topic of solar photovoltaic. This is Albert Einstein's course, and regarding we shall require a sustainably new manner of thinking if mankind is to be survived. So this is very important things, and you will find the answer. So why we require a new kind of thinking if you want to survive in this world actually. So you will get the answer during this whole section regarding this sentence. I just want to give the quickly introduction because Mr. Manisar is already giving the lot of introduction, but I just want to highlight and thank you. My name is Baba Sahib Mukane. I did MTech in energy technology. I'm a fascinated energy leader I have almost 13-year plus rich global experience in this, in the leading of engineering management for the solar photovoltaic, energy efficiency, energy audit, in its management, project planning and management. So I have very good command on the techno-commercial management of overall the industry. As per so far, I'm leading the engineering, commercial, and project management department. Globally, I lead almost 15 megawatt plus solar photovoltaic project across the world, which is including in the India and the Gulf regions and the African countries, which is including different kind of the solution, which is grid connected of grid and mini grid application. In addition to this, I'm taking a lead of the solar thermal power plant, almost 5,000 meter square solar thermal power plant. I have completed the installation, which is used for the industrial process heating, cooling, and the cooking application. Successfully, I have handled almost 15 million energy related projects across the world. I'm expertises of energy audit and its management to conducting the different industry, which is including cogeneration power plant, sugar mills, distillery, feed mills, poultry, chicken processing plant, hospital and education sectors. I'm involved and develop a setup of plastic waste to oil generation, and this oil which can be used for the subsidiary of the diesel. This is very important task, which as I was working on this project and developed this complete setup for plastic waste to the oil generation. I'm skillfully involved, develop an international patented technology, which is called as a, Inerson curvilinear Fresnel reflector. This is used for industrial processing application. I was interviewed in Sam TV, G News channel regarding this global warming lecture, and I got recently award as the topmost global listing as an energy leader and solar leader. Actually. This is some of my professional engagement. This is some of the awards and the TV interview I was given. Some of this environmental section actually, and this is 2 awards I have received recently. Now today's outline, before the starting of my actual lecture, I just want to highlight our today's outline presentations. The first important thing I just want to highlight is the introduction of energy and its sources. Energy, renewable energy, and why we use the renewable energy, job opportunity in this sector actually. Introduction to the energy. You know how much everybody knows about how much energy we have used since March. Could you manage to come here without energy? No, energy is our life actually. So energy is nothing but the ability to do work. Different types of the energy sources. There is a there is 2 type of energy sources. The first is a renewable energy and non-renewable. Renewable energy is nothing but the solar, biomass, wind, geothermal, and the hydropower. So non-renewable energy sources nothing but the coal, natural gas, nuclear, and the fossil fuel, which are used for the different power plant. So you know why we have to use the renewable energy. So what is important? You get the answer of this question. You know, India is consuming almost 5 million barrel oils per day. This is in 2016's data actually. We are the 3rd rank in the world for the oil consumption country. So almost we produce the 1 million barrel oil per day, but we are importing almost 5 million. Means 5 times oil we are imported from the other countries. So India is imports 96% of oil consumption throughout our uses. In addition to that, we are import the coal, gas, and the nuclear fuels. So you know, if India holds almost 4 and 7 to 8 millions barrel oil which are existing available with us, and if we can stop the importing and we use our existing resources, so we can manage up to only 3 years periods of left. After that, what is this? Means that's why we need the thinking of the renewable energy. I just want to play a small video so that you can get the idea. So why we require the renewable energy actually. Mane sir, is it audible? Mane sir?
No,
Hello?
no.
Is not audible? Now? Hello? Mane sir, now is
Yes, sir.
Huh? Hello? Hello?
Hello.
Now the sound is audible?
Yes, it is.
Please play the video, sir. Sir, video is not audible.
Video is not audible?
No, sir.
My screen is visible, na?
Yes, sir. Yes, sir. Screen is visible.
Now it is audible, na? Hello?
No, sir. No, sir. Video is not audible.
Audible, sir.
Hmm? Hello? Anybody can tell me? It's audible? Hello? Hello?
All the participants are requested to mute your mic. Hello, sir. Video is not audible, sir. Video is not audible. I can reshare the screen again. Yes, sir. Now the screen is visible, no? Correct? Yes, sir. Now it's visible? Yes, sir. Huh? Now it's okay, na? Yes, video is visible, but not audible. No, I just haven't played. Sorry for actually that is some. Now? No, sir. Okay, I think. So we have tested, sir, before 15 to 20 minutes ago. That time it was audible.
No, it's not audible.
No, sir.
Okay, leave the video. We'll drop the video. That's not.
Yes. Okay.
Okay, that's sorry. Actually, there is some technical issue due to the video is not audible. So that's the reason we need to focus on the renewable energy. So this is the statistical of the renewable energy, currently energy statistical in India. You know, the electricity coverage, almost 99% of electricity we are installed capacity is almost 370 gigawatt. And it's there is a different source resources. We are using the fossil fuel, renewable energy, and there is a statistical figure which is in a current condition of the India actually. So in presently, India is almost 14 gigawatt solar power plant is installed in the up till in 2020, and which are having the different kind of applications: street light, home light, solar lantern, solar pumps, and standalone solar power plant. So this is the overall India map, which the different regions the solar power plant is installed. So the population and economical growth, in 2060, if you see the 2000 to 2020, is almost every year our population growth is increasing 1%, and today is almost 1.4 billion people. This is the population of the India. We are the second largest country in the world for the population. If you see why I just want to highlight it this, the gross electricity consumption in 2018 and 19 was almost 1,200 kWh per capita. Okay, in 2000 it's per capita. Almost we have the 1.4 billion. In 2016, almost in 734 kWh. This means that almost 10% electricity usage is increasing in India in last 2 years periods, okay, means 16 to 19. So means globally, if you see the globally, is almost 2,600 kWh per capita energy consumption. This is the India, this is a globally. And if you compare these European countries, is almost 6,200 kWh consumption, electricity consumption of per capita. And if you see the India, is 1,200, means we are far away. That's why we require the renewable energy sources to sustain our life, because we have these other sources, fossil fuel that has to be, we are 96% we are depending upon the imported from other countries. So, in electricity, according to the World Bank's figure, shows around 200 million people in India still they lack of the electricity, which we will not go to the this coal-based power plant due to the transportation and transmission distribution losses. So these are the 200 million people, they can't access the electricity because of the limitation of the existing non-renewable sources. So this is one of the picture we are completed of the project. It is in one village. We don't have here that there is a light, and after the installation of the solar power plant, they get the access of the electricity. So, according to to keeping this vision, the Ministry of Non-Renewable Energy and the government is set up the Jawaharlal National Solar Mission, which is launched in January 2010 by ex-Prime Minister of Manmohan Singh, and he's taking the target of 200 gigawatt solar grid-connected power plant. So after taking a charge of our Prime Minister Narendra Modi ji, today he just approved the stepping of the solar India solar power plant from 20 gigawatt to 100 gigawatt. So this is a huge requirement of the solar energy in India. So this target is compiled in two figures, that is 40 gigawatt for rooftop and 60 gigawatt for large and the medium scale grid connected power plant. For this 100 gigawatt solar power plant installation, we around require 6 lakhs crores of investment. 6 lakhs crore of investment in India is required for setup of this 100 gigawatt solar power plant. So, this is the very important slide. We in India, it's government of India is set up 100 gigawatt power plant. For this 100 gigawatt power plant, we require the manpower. And we have the job opportunity in Indian regions. And that's the region is nothing but, you see 100 gigawatt power plant capacity, its requirements. Let's take an example of 100 kilowatt. For the 100 kilowatt systems, we require one senior people, one junior people, 3 numbers of junior people, unskilled laborers, we require 4 numbers. So total numbers of resources is required 8 numbers. So typically these education required for B mechanical, B electrical, diploma, ITI, and 10 pass peoples. So per megawatt, almost we require 60 to 80 numbers of resources for these typical resources. Okay. And we want to install the 100 gigawatt solar power plant, means 6 million job requirement available in India for the completion of this type of the solar photovoltaic project. So this is a huge requirement for the employment in India regarding the solar. So what kind of the specialization is required for this sector? So there is a different kind of specialization. There is R&D and manufacturing, project development and consultancy, installation, commissioning, testing and operation maintenance, marketing. So these are the different kind. Now this now coming to the IoT application, this computer engineering also playing the very big role for Python analysis, then data analytics. There is a lot of requirement available in this sector actually. So, conventionally route for providing the power we have tried from last 68 years now. It's need time, it's need resources, it's need money to supply the power to all. Even if we achieve this, is this the best way to power our houses, our campuses, our industry? Is there any alternatives? Yes, there is an alternative. So what is that alternative? Solar. So solar energy, we have using the solar since our birth. Yes or no? Yes, of course we are using. It's a it's a clean, pollution free. And this other renewable technology also is very good option for replacing this fossil fuel based power plant actually. This is the interesting slide. If you see the solar energy in India, so why we have to use why the government of India is taking very big target to sustain our country by using the renewable resources. Reason is that, so the most part of the India is receive the solar radiation almost 4 to 5.5 kilowatt hour per meter square per day. If you see, this is our country map and this yellow color, and if you see this all our region, we are getting a sufficient solar light to generate the power from this solar photovoltaic technology. And for 1 kilowatt solar power plant, it's required 10 meter square land. Means 10 meter square shadow free area is nothing but 100 square feet area. Our every rural houses or the city, we have the sufficient land, means 100 square feet land available for everybody, and they will install the minimum 1 kilowatt power plant, and that power plant will generate a 4 to 5 kWh per day. So this is the typical, now the in current existing condition, the price in Indian market is solar PV is almost 40 to 45 watt. That is, this is the price for this per watt for installation of the solar PV plant at your premises. Now this is the solar thermal cost is of means 10,000 to 20,000 per meter square of the collector area. This is the important terminology. When we design the solar system, we need to understand this kind of the terminology. What is the solar radiation? The radiation received from the sun is nothing but the solar radiation. But what this radiation received, there is a different kind of radiation. One is the beam radiation, second one is the diffuse radiation, and third is the reflector radiation. So what is the beam radiation? The radiation which is directly received from the sun, which is incident our solar photovoltaic panel or our houses, that is called as is the direct beam radiation. What is diffuse radiation? Diffuse radiation nothing but the radiation which is scattered from the atmospheric impact. There is an ozone layer is there, cloud is there, and whatever the radiation coming from during the scatter, that is called as a diffuse radiation. And what is the reflector radiation? Once the solar radiation is incident on our surface, it can be reflected due to the grass, sea, and our surface of the terrace. So that is called as a reflected radiation. So this is the important terminology when we design of the solar power plant, which can you use. The peak sunshine hours means what? The sun is starting at morning. Let's assume the 6 o'clock from evening at 6 o'clock. During the period, there is the radiation is varies. What is the peak sunshine hours? Peak sunshine hour is nothing but the maximum hour we are getting 1,000 watt per meter square solar radiation, and that is called as peak sunshine hours, which is figured from 4 kilowatt to 4.5 kilowatt in Indian region. The sun location and the geometry of the solar panel. Once you are going to somewhere and you are finding about the solar PV plant is installed, and you are never seen the solar PV plant is flat to the surface. So reason, anybody knows why this solar PV plant is not flat to the reason? Okay, I will tell you. The reason behind is that suppose let's assume this is if you keep the solar PV panel is a flat, there is let's assume there is an incoming of 12 radiation of the sun. Only the almost 9 radiation we are captured and 3 radiation we are not captured because of its latitude angle. It's directly parallel to the surface. So if you make the perpendicular so that we can catch up all the solar radiation, and it can be used to get more energy. That's the reason we are keeping the model facing towards the sun, which is an angle that is called as a latitude angle. There is a different kind of the technology available in the solar PV plant. One is the solar cell technology, and second is the solar thermal technology. So what is the solar PV technology? The solar PV technology is nothing but light is converted to the electricity. And what is the solar thermal technology? It is the light is converted to the heat. There is a two most important differences that light is converted to the electricity, then we call it as a solar photovoltaic technology. And when the light is converted to the heat, then we call it as a solar thermal technology. So this is one of the video. Manisha, this is also you are audible this video. Hello.
Sir, please play the video. I will check, sir.
This is audible.
No, sir.
Right. There is some issue. Anyway, I just want to understand. There is a different kind of the technology in a solar photovoltaic panel. The first technology is that's called as mono, poly. This is a half cell solar PV panel. This is a bifacial solar panel. This is the flexible and this is the thin pin. So what is the mono? Mono is nothing but the poly is multicrystalline and mono is a single one crystalline. This is the half cell technology is just recently coming into the market. It can be used to reduce the I square R losses. Anybody having the electrical background, they understand the I square R losses. This will reduce the I square R losses, means reducing the current. This is the current trend is going on. Earlier trend, this mono and poly is used. Now poly is gone out. Everybody is trying to get the mono, half cell, and the bifacial. So this bifacial model, which is used to generate the power from front side also and the back side also. So before I was already explained that reflected solar radiation. So reflected solar radiation, there is a light is coming from upside, that is called a direct incident, and the light is reflected from the ground, it's called as reflected. So both type of radiation is captured by using this model. So that's why it is called as a bifacial model. So as compared to this rest of model, this model will generate almost 15% to 13% more energy. I think this is one of these three video is very interesting, but after the completion of lecture, I will try to play once again. If you understand this, this you can get the voice or not, Manisha? Manisha?
No, sir. This video is also
We
not
will
audible.
see after completion of the lecture. We will see how to play that. That's not an issue.
Yes,
So
okay, sir. Okay.
solar PV application. There is a different types of the solar PV application. This is called as grid connected solar PV plant. This is this side. You can see the solar PV plant. This is the solar PV panel. After that is an inverter. This is the distribution box. This is a bidirectional meters, and this is the transmission. For that distribution, I will go to the substation and feeder, and we get the electricity. So this is kind of the grid connected solar power plant. This is called as green detector with the battery backup. So this is the same concept. We added the battery only, and then it is inverted, and it can be go for utility by using the bidirectional meter. And some of the parts we can use for our house. So this is called as a off-grid application. The second is a mini grid. Mini grid, we have the different kind of the technology. It is some of the nuclear power plant is available, wind energy is available, the solar is available, and this is called as microgrid. And this grid is used for this. Let's assume in Pune like city, and they have their own grid and they supply the power for their particular cities actually. This is typically a off-grid application. This is a typically solar PV installation which is used for the ground-mounted solar PV plant. This is a rooftop. Means in our rooftop, right now we are seeing the solar power plant. So this is called as rooftop solar PV plant. This is a flash mount. Means it can be installed on the industrial shed, and this is a carport parking. We are using this right. Now, I just want to teach you how to a very simple step within 5 minutes, how we will design the solar power plant. That I want to teach you. And anybody want to interested, they will write the steps actually. So understand the steps of design of grid connected solar power plant. So this is the market trend right now. Everybody is using. The first important thing is that we need to understand our existing energy pattern and its energy consumption. This is the first step. Now, second step, the peak sunshine hours. I had already explained you in Indian region, if you consider as the peak sunshine hours is almost from 4 to 5.5 kilowatt per hour per meter square per day. If you consider the Pune, we have to consider 4.5 to 5 for the design parameter. The solar, then the third step, we need to select the solar panel, then the inverter selection, and third one is the string sizing and its electrical connection. So let's assume we will take just taken the one of the example of the typical home. If you see in typical home, they are using the fan, tube light, CFL, refrigerator, ACs, heater, and LCD TV. I just taken the wattage of currently and how many number they are. This is the typical example I'm just taking. The total number of wattage, if you multiply by numbers, this connected load of that particular appliances, this what is rating of appliances, multiplied by total numbers of equipment or appliances you are available, you get the total number of wattage. After that, how many hours that appliances you are using, so that it can be multiply that and then you can get the energy. Means there is a difference between the power and energy. So energy is nothing but the power is nothing but the rating, and energy is nothing but per unit time. So that's why you have to multiply by uses and you get the energy. So I have calculated the total energy required for per day. So I hope this is clear everybody to right now. So means that we need to understand the energy consumption. After that, we need to find out the rating, then total numbers of appliances available. Then we calculate the total number of wattage. After the wattage, we have to multiply by how many hours we are using these appliances, and you can find out the energy, and then you can do the summation. So means that you just calculated we require almost 22 kWh of energy per day, and which connected load is almost 3.3 kilowatt. So this is our requirement of our home, a typical. For example, so our peak sunshine hour in Pune, I have considered 4.5. So if you divide by this, you will get the number of 4 kilowatt. 4 means we have to design the solar PV plant for 4.5 kilowatt peak. For example, I have considered 380 watt panel. So 380 panel means 4.5 multiplied by 1000. So you get the wattage, and divide by 380 so that you can calculate the total number of panel is required. The 10 numbers of panel. So means 3 point, then I have to, once I have calculated the panel, I have selected panel. My panel is a 300 watt peak. And how many panels I require? I require the 10 numbers of panel. The next step is that I need to find out, or I need to select the inverter. So what I did, I have selected the inverter is 3.6 kilowatt because my connected load is 3.2 and the nearest inverter is 3.6 kilowatt. Which voltage, because our home we require 330, this single phase system, 230 volt, 50 hertz frequency. I have selected to do AC to DC ratio is 1.2, means that there is a grid limitation. See, suppose you are putting a solar power, you are connecting the solar power to inverter. What maximum rating we have considered is 1.2 times of extra solar capacity we are connected to the particular inverter. So this figure you will get from the inverter data set. So now, if you find you are selecting the inverter, you are selected the solar PV panel. Now we have to, according to the inverter configuration, we need to connect the solar PV panel for parallel and series mode so that we can match that inverter window. So what I did, this is the inverter window of 80 volt. Its cut off voltage is 80 volt, and the 550 volt is maximum voltage. So that I need to connect this model. This my 48 volt model connected 10 numbers of model together. They get this much of the voltage. So this 4.2, this inverter capacity, and this is the inverter specification. I will show to the next slide. So this is the typical monocrystalline model. This is the data set of the monocrystalline model. So this is the size, width, the capacity I have considered. This is the rating. And this is a typical installation. This is the inverter I have selected. This is called as a grow-out inverter. So we have selected 3.6 kilowatt AC output inverter. This is the particular data set we are using. Okay. Now the second, I hope this is very clear how to design the grid connected solar power plant. There is a very simple 5 basic steps. Whatever the skill, whatever I have, I make the simplified and I just explain the 5 different steps you need to follow. First, we need to know energy consumption. Second, we need to find out the peak sunshine of the particular region. In Indian region, we have to consider 4 to 5.5 kilowatt per hour per meter square. We divide this, we get the total number of PV capacity, then you select the model, then you select the inverter, and then we connect the solar PV panel parallel in series conjunction so that we can track this inverter specification or connection. Now the second version, so we need to collect, we need to design the upgrade solar PV application. Grid connected upgrade, what is difference? We need to add the batteries to store the energy so that we are independent on the grid. So in earlier case, what we designed for earlier case, we require the 4.5 kilowatt systems. But in here, off grid, we require 5.5. The reason is that some of the energy we are using for our daily needs and the rest of energy we need to store in the battery so that we can use for next, I just consider 2 days autonomy, so that we can use this energy for next 2 days to if the solar is not available. So that's why it's called as upgrade. The same step we need to follow. We need to consider this. We have the figure of the energy consumption. Then we need to consider the inverter. Then we need to consider the charge controller, means nothing but again the inverter, battery charge controller. And this is the battery design. So battery design is very simple step. We have the energy. In the second step, we calculated our energy requirement. So autonomy means that if the solar is not available for 2 days, so that I have considered the 2 days autonomy. Then I have designed the system voltage. That is the inverter parameter. According that, then DOD, depth of discharge of battery, I have considered. According that, I have to calculate the total energy requirement. And after that, I have come to the solar PV model. In earlier case, what happened after this energy, we have directly calculated the solar PV model and then we select the inverter. But here we have to select the battery so that we need to extra energy store in the battery so that we require the extra capacity. So the reason that solar PV model selection is after the design of the battery. So solar PV plant capacity, total energy, we after calculation selection of the battery, and that's peak sunshine hour, and then we calculate the total numbers of models required for that. This is typical Excel set. Same case study I have considered. So the step number 3, energy requirement. Step number 4, DOD, this complete design. So earlier case, we require the 10 numbers of model, but this case we require the 14 numbers of model. It means this four extra numbers of models is used to generate a more energy so that we can store in the battery. If the solar are not available for 2 days, the same energy we can use our home to power the home. So this is the typical grid connected and off-grid application. Now, we understand what is the solar PV technology, what are the different types of the models, how to design the solar PV power plant. But during the design, what important factor we need to consider that we need to understand. The shadow analysis. Shadow means the shadow is very important factor for the any kind of the solar PV plant. Reason is that I just want to show you one more. If you see this model, solar PV model, this is connected to the series together. If I get the shadow on this portion so that the current flowing path is stopped, it will be impact of overall series connected panel. So that shadow is very important factor. We need to understand the tree near from our houses, any other in our terrace we are putting the dish TV antenna. We need to see how much is far away from that. So we need to calculate that. Means that the shadow is very important parameter. Second things is that the sun availability means solar radiation available in particular place. That is called the sun's peak shine hours. Then the temperature. And the third one is that soil also we need to understand. Then whether our plant is not near from the sun because its evaporation start, some of the salt can be deposited in our plant. So that this factor we need to consider during the design of the solar PV plant. This is the typical, if you connect last case study, if you see the last case study. So this is the series and the parallel connection of the model. There is a 4-wire panel is connected to the series. If you connect to the panel series, the voltage get added and this current will be remain same. If you connect to the parallel, voltage will be remain same and the current getting increased. According to the inverter selection, we need to connect how many model connected in the series. So last time we have calculated 10 numbers of models so that we have connected the 10 numbers of model of series. So this is the battery connection, the same factor, battery and the solar PV also. This is our last case study, string voltage. So I have the 10 numbers of model. So I have connected the 10 number model in the series. So if I connected the 10 numbers model in the series, my voltage rating is 39.70 multiplied by 10. I get a 397 97 volt DC voltage, and my current is 9.8. So according that, you need to select this series and parallel curve, because see, this MPPT range is 50 volt to 550 volt. Means I need to connect 10 models in the series so that I can this minimum and the maximum window, so that I can generate a maximum power. This is the effect of the temperature. Temperature indicates. See, the shadow. The shadow is important factor. The point to be. So the generally the thumb rule. What happened in the as per the solar and sunshine calculation. Let's assume we have the tree for 1 meter height. So it's the tree having the 1 meter height. Its shadow goes for the 2 meter. Means double almost. So if we can make the double for thumb rule, so that according if I can install the solar PV plant in my terrace, I have the dish antenna, and the dish antenna is height is almost 1 meter, so that I can put the solar PV plant up after 2 meter high, 2 meter length from the away from the dish antenna, so that it will get the maximum power and it will generate the power throughout the day without any impact. So that's the reason the shadow is important factor. Point to be considered. This is the inclination angle. Last time we considered, I just explained, we are not keeping the panel is flat. Reason is that we are missing the solar radiation. So we can capture the maximum solar radiation. That's why we are keeping this in an incline towards facing to the sun. This is typically SLD, which we can refer. This is typically SLD for using a solar PV plant. This is the typical case study. There is a string number 1, string number 2. This is 1 to 13 numbers of panel connected series, and 1 to 14 numbers of panel is connected to the series. So this is DCTV. This is DCTV box. This is an inverter. And then it is a ACDB. ACDB is nothing but our panel, electrical panel. So we are connected here, and then it go to the grid, and we are synchronized here to the grid. It's typical case study. This is typically AutoCAD layout for the one of the terrace. If you see, this is one of the terrace. If you see, this is a solar PV panel installation. This is the one single row having 1x1 model, and this is the another row we have the 2x2 models. And this is the structure how we can do the piling and all these things. Okay, I just want to tell you one. This is a joke actually. There must be a source of energy down here. So means I'm just why you people are looking at down to find the source of energy. If you look to the up, you can find the sunshine is available, which can give you the more energy to us. So thank you from my side. I hope I'm getting more fastly, but I just want to cover the presentation. If anybody having the question regarding the career opportunity or anybody's, I will take 3-5 questions so that you people understand what are the important parameters we are you need to consider during your career regarding this sector of energy and solar. So Mane sir, hello. Hello.
Yes, sir. Yes, sir. Yes, sir.
This I can try
Okay,
once
thank you,
again.
sir.
I can stop this
Yes,
screen
yes, sir.
sharing.
Sir.
That video is very
And
important. It can give a lot of motivation actually.
okay, sir.
It's so you are visible or not? Hello.
Video is visible, sir, but it is not audible, sir.
Okay, then leave it. There is some issue. Last time we played. Okay, we'll take the question if the students having some question regarding the career, so I can guide them. Actually.
Before going for the discussion session or question answering session, all the participants are requested to unmute your camera so that we will take the photographs or we will take the screenshot of the today's session. All the participants are requested to unmute your video.
I hope everybody is enjoying the lecture. There is some issue that's extremely sorry from my side due to technical problems for sharing the video, but the video is very interesting and I will send this video to link to Amol sir and you people will take the video from there. And just an open question, I will take a couple of questions as per your timing and everything is scheduled regarding your career opportunity. There is a lot of opportunity in this sector for the mechanical, electrical background, computer background, and IT sectors. Okay, Minus sir, you can continue. When I can take the question, I will take move forward. Question. Okay.
Okay, all the participants are requested now to mute your video. And now session is open for the question answering. If you have any query, then you can ask to the sir.
I'm expecting the question from the student actually, especially because it's very important. I need to understand whether they catch the lecture or not.
Hello, sir.
Yeah,
So
yeah.
I have a question.
Yes.
So when it comes to the efficiency of solar panel,
Right.
it is only up to 25%, 25, I guess. Hello.
Yes, yes.
Am I audible, sir?
Yes, yes, ma'am. Yes, ma'am.
Also, my question is, when it comes to the efficiency of solar panels, it is very less. So can you state some opportunities for the research and in the field of solar panels?
Can you repeat the question because your voice is not properly someone getting properly. So you're talking about the efficiency
Am I
as
audible,
almost.
sir?
Ma'am,
I'll
from
type
your
the
side, is
question,
the
sir.
echo is there.
So that it will be
Echo
clear.
Echo
means I
is there
think there
from
is
your
two
side.
sign now, two sign completed. I think there is a desktop and laptop also. So either you can mute one side so that it can be clear wise. Anyway, you take the next question. Okay, then I can assume equally I have a question.
To type your the question in the chat box.
Okay, I can tell you the career related things. Electrical engineering background students, you peoples need to understand these SLD related parts is very important. Some of the electrical parameter you need to understand. If you want electrical mechanical related students, you people need to hard school command of the electrical part, that is SLD, electrical engineering, SLD, PVCs. There is software which is internationally recommended for the solar plant design. This must requirement you people having the time, so that you need to complete that software courses, that is called as PVCs, helioscope, SketchUp. These are the internationally recommended software and this most important software, because in I just seen in our Indian regions what our students whatever that they have to learn, they learn after completion of their course. After completion of BE, they think, okay, I need to go for this sector. Okay, I'm missing this software. So you need to fix your focus where you want to go. Your aim is need to the fix, so that if you want to do the career in energy and the solar sector, you require the by hand of AutoCAD, mechanical background. AutoCAD is required, must. ANSYS is required, must. Then the PVCs, Heloscope, SketchUp. These are the 5 numbers of software is most important for the mechanical and electrical background. And the computer engineering background, you need to understand the Python, because the Python right now for the data monitoring and data analysis. In our sector, we have a lot of scope. For that require the Python must, means data analytic, any type of data analytic course, and some of the languages is required, so you can get the more idea about that. Uh, If anybody having the open question regarding career, student, please kindly ask.
Yes, participants.
And if you require any kind of the support regarding the career and future job opportunity, if people can take my number from Amol Mane sir, and my mail ID is there. But I'm working in out of India, so that better I'm requested please drop to mail, which can be help me to the answer instead of the direct calling on the mobile number. Mane sir, that's it from my side.
Hello, sir.
Yeah, Mane sir, tell me.
Yes, sir. So one question is there from ma'am that she has put in the chat box regarding the conversion efficiency of the solar panel. So as there are different types of the solar cell, that is monochromatic mono and poly solar cells. So what about the conversion efficiency of the both?
You see, overall conversion, if you are talking about overall conversion efficiency, if you have the model almost, you consider the 380 watt peak solar PV model. It's meaning that the 380 watt peak solar model, it will get the 380 watt at maximum time. Okay, the overall conversion efficiency is up still now is not more than 20. Is 90% efficiency, but that is a sufficient efficiency because in that can be right now there is a lot of research is going on, and the coming days the solar panel go to the 20 to 20, 25 to 27% of efficiency actually, but overall efficiency is on 19%. 19.
Okay. Thank you, sir, for your valuable guidance. Now I request Dr. A.G. Devkar, sir, to give the vote of thanks.
Hello. Hello. Hello.
Yes, sir, I can hear you.
Yes, sir, you are audible. Yes, sir. Thank you, sir. So now this is time for a vote of thanks. So on behalf of Sant Gajanam Maharaj College of Engineering, Magaon, and Institutional Innovation Council, I am very thankful to Mr. Babasaheb Mukni sir for conducting session on problem solving and ideation workshop. We assure you that your expertise will definitely help to students in their future career. I also would like to thank Honorable Principal Dr. S.S. Sawant sir, students and faculties members for attending this session. So all in all, thank you, sir, for conducting this wonderful session.
And especially thank you for the institution and all your college staff and the students for listening the lecture and giving me the opportunity to explain the industrial thoughts with you people. And it's my pleasure to talk with you. There is an excuse from my side due to the technical issue. I can't play the video, but I can share the link with the Mane sir, and you can watch the video at any time when you are comfortable. So once again, thank you so much for me giving me the opportunity regarding to me. Okay, thank you so much, Mane sir.
Thank you.
Thank you so much.